All right, so I believe this is recording. Let's take a look at solving this inequality. It has fractions in it. Students sometimes have anxiety about fractions, but with practice, you'll get better and your confidence will grow. Um, on the left-hand side, I'm really not going to do anything with it yet, so I'm just going to copy it over. Other than I can write this as this x in the numerator, 15 times x. That might help people in the future steps here. And I've got less than or equal to. I want to distribute this 7/4 to both terms. So when I multiply it times this 1/6, 7 times 1 is 7, 4 times 6 is 24. Uh, put the x here in the numerator, plus, when I distribute to the second term, 7 times 4 is 28, 4 times 5 is 20, and then I've got plus half of x, or x divided by 2. Now, if we when you have very large numbers or lots of numbers like this, and you're trying to find the least common denominator, it may help. It helps me. I'm not very good at mental arithmetic. I don't sit there and always see I can get a common denominator just by multiplying all the denominators together, but then I'm going to have to reduce my fractions, and the numbers are going to probably be pretty big. But if I look at the prime factorization and then look at each individual factor and pick the biggest exponent that appears, I'll be able to find the least common denominator. So let me illustrate what that is. What I mean by that: 30 is 3 times 10, but you've got 2 times 3 times 5 is 30, and these exponents are 1. If I look at 24, 2 times 12, but 12 is, I've got 8 times 3, 24, 8 is 2 to the third power times 3, and then I have a 20, which is 4 times 5, 2 squared times 5, and then I have just the number 2 that I'm simply going to look at as 2 to the first power. So my least common denominator, well, I see that I have a factor of 2, and of all these exponents on 2, I can see that 3 is the largest exponent that 2 has. And I see that I have at least one factor of 3 in here, and the largest exponent on it is 1. So I've got 2 to the third times 3 to the first power. I see that I have a 5, and the largest exponent on it is also 1. And those are the only prime factors that I see. So my least common denominator, 8 times 15, and what is 8 times 15? But 120. So I wouldn't have been able to, other people I'm sure can either in their head or just kind of look at the numbers and they have a good number sense and guess, or they'll count by eights, they'll count by 30s, they'll count by 24, count by 20s, count by twos, and they, all, and the first number you end up on that's the same is the 120. So I know now that I'm shooting for a denominator of 120. So this 15x over 8, I'm going to multiply it by the number 1. And also, when I have this prime factorization, I can easily see that 8 times 15 is 120. So I'm going to multiply this by 15 over 15. Now, my next term here, the 30, I need to get it to be 120. And I can just see that 30 times 6, or 30 times 4 is 120. So 4 over 4. But I could come over here and look at this as well and say that 6 times 5, that 6 times 5 is 30, and 2 squared is 4. And I can, shuffle, I can look at those prime factorization, and I can see what I need to multiply by. So here for 24, I need to multiply 24 times 5 is 120. So I need to multiply by 5 over 5. Now I need to shrink this up a little bit. Well, all right, let's go back to the 28 over 20. Now I could have, I'm definitely could have reduced that to 7 over 5. I suppose I could do that now so that the numbers stay smaller. 28 divided by 20, both of those share a common factor of 4. 28 divided by 4 is 7. 20 divided by 4 is 5. And I know that 24 times 5 is 120. And then here, x over 2, that 60, 2 times 60 is 120. That's easy to see. All right, so now with a common denominator of 120, if I multiply all of these terms by 120, all these denominators cancel. And since I'm multiplying by a positive 120, the inequality, the arrow does not change directions. So I got 15x times 15, which is 225x. I've got 107 times 4, and 107 times 4, I'm getting is 428. Now you should check me as we go through this. 7x times 5, 35x. 7 times 24, 168. And we've got 60x here. So let's leave the left-hand side alone for just a second. And the 60 plus the 35x, 60x plus 35x is 95x, right? Let's take away 95x from each side. So if I've got 225 minus 95, 130. And let's take away 428 from each side. So we've got 168 minus 428. And if I've keyed that in correctly, I get negative 260. And yeah, if I divide by positive 130, then I get a negative 2. And so that's our solution to this, that values of x are less than or equal to negative 2, but they want me to write that in interval notation. So it's here, sometimes until you get used to it, it might be wise to make a sketch. You're including negative 2, so it's a solid dot. The arrow's pointing to the left. Values that are x is less than or equal to negative 2 means you shade to the left. And so we have in interval notation negative infinity to negative 2, and definitely make sure that I can read that bracket. If your handwriting is too sloppy where I can't determine whether that's a bracket or a parentheses, then you're not going to get full credit for it. So, hey, I'll talk to you later. Hope that helps. Well, where's my mouse? Bye.